have on here is a definition of continuity. So we are going to be talking about where functions are continuous today. And continuous, if we're talking about a very informal definition, it's just where you can draw the graph without picking up your pencil. Anywhere you have to pick up your pencil, there's a break in the graph, it's not continuous. Otherwise it is. We will talk about continuity. I'll say where is this continuous, and you're going to give me an interval. Just like with increasing, decreasing constant, your interval has to be using the x values. So we'll use interval notation. Only time you're ever going to list y values in an interval is for the range. Otherwise, we're always going to stick with the x. So the first thing, I just put some graphs up and asked you to tell me where it was continuous. So if I'm looking at A, and I apologize, this is very hard to tell. There is an open circle right here. Where it went through my dot, it kind of looked like it filled in where it hit the x-axis. So at 0, 2, that is supposed to be an open circle on your graph. So if I'm drawing this, going from left to right, I'm drawing it, but what happens when I get to that open circle? You have to stop, pick up your pencil, go to the other side. So it is continuous from, we're listing the x values, so it's coming from negative infinity until I get to where x equals 0. Is it actually continuous at 0? So parenthesis or bracket? Parenthesis. Union, you pick back up at 0 and go forever. So 0 to infinity. Okay, B. Got this zigzag. Do I ever have to pick up my pencil? So where is it continuous? C. Is that one going to be continuous? We have to pick up our pencil at 2. Make sure you're putting parentheses there because it is not continuous at the 2 itself. And D. What about that one? Right. We never have to pick up our pencil to graph that forever. So do you guys understand what it means to be continuous and not? The next big piece that we're going to look at are all the different common functions. So you guys have seen most of these before. We're going to be getting into a lot of transformations. So these are the common functions that you are expected to know what they look like and be able to draw a graph and answer questions from those graphs. So our first one is just the identity. F of x equals x, y equals x. What is that? A line, right? A line with a y-intercept of 0 and slope 1. So draw your line on your notes. Hopefully you can draw it somewhat straight. Okay, I may ask you questions about this. If you look in your book, when it goes through each of these, it gives a whole box full of information. And it tells you domain, range, increasing, decreasing, constant, continuous, all of this stuff. And I didn't want to put all that up here because I don't want you to think that I expect you to sit and memorize all of that. What I expect is that if I give you this equation, or if I say identity, you could draw a graph. And then could you look at the graph and tell me things like the domain and the range? So what is the domain of this? Negative infinity to positive infinity. What is the range? So it's up to you if you want to write all this down, but I just want you to be able to draw the graph and answer questions from the graph. Is this one ever, or where is that one continuous? Yeah, that one's always continuous. Is it increasing, decreasing, or constant? Increasing. So could you guys answer all those questions? Okay. Let's go to the next. So this time we have the square function. F of x equals x squared. So what would this one look like? A parabola. Now, what should I do if I'm asking you to give me a precise graph? Okay, make a t-chart. You don't necessarily have to write out your t-chart. We're going to graph these so much. If you can do it in your head, just kind of talk your way through it, that's fine. My general rule, I require a minimum of 3 exact points on anything you draw. Now we can obviously do more than that, but certainly no less. So if I put in a 0, 0 squared is 0. 1 squared, 2 squared, 3 squared, -1 squared, -2 squared, positive 4. Negative times negative makes positive. -3 squared. Do I need to write out my t-chart, or do you guys know where I got that? I just squared my x values as we went through them. So, connect that, and we have our graph. What's the domain of that parabola? Right. As it extends, it's going to keep getting wider and wider. So eventually it will hit every x value. So our domain is negative infinity to positive infinity. Our range is talking about our y's. Think about from the bottom up. So the first y value we hit is 0. We touch it so it gets a bracket, and it keeps going up forever. There's no breaks in this graph. It's always continuous. What's this first section doing? Increasing, decreasing, constant? Decreasing from negative infinity to 0. And then from 0 to infinity, it is increasing. Good. Any questions there? Let's look at this one. So a cube. Do you remember from last year what the cube looks like?
Not zigzag, but like chair.
Yeah, it's like the chair. It's
yeah.
Only one place in the middle. So let's just plug in some points. 0 to the third is 0. 1 to the third is 2 to the third 8. -1 to the third 2 to the third
8.
So we get that chair looking graph. What's the domain of that one? Negative infinity to positive infinity. The range. Is that one increasing, decreasing, or constant? Increasing the entire time. It kind of flattens out a little bit in the middle, but it never stops rising. So that one's increasing from negative infinity to positive infinity. Questions there? Are these going okay? Do you remember seeing most of these graphs before? These were the ones that you saw a lot in Algebra 2. Square root function. F of x equals the square root of x. When I go to make my t-chart, can I plug just anything in here? No. What do I have to plug in? Positives. We can't do the square root of a negative, can we? Also, let's make our life easy. Like, do I want to put in a 2? Do I want to do the square root of 2? Okay, let's put in some numbers that give us a nice answer. So if I did a 0, square root of 0 is 0. So mark that one. Can I do the square root of 1? And that would be a 1. Square root of 1 is 1. What else? What's another nice one? 4. Square root of 4 is 2. One more nice one. 9. Square root of 9 would be 3. We can't do negatives, so our graph looks like this. What's the domain of this one? Right. It starts at 0 and goes forever. So bracket 0, comma, infinity. What's the range? If you're looking at your y's, your lowest y value is also 0 and it continues to go up. So the range is the same. If I asked, is this increasing, decreasing, constant? What is it? Increasing. Good. Questions there? Cube root. Do you remember what that one looks like? Yeah, it's like a sideways chair. Let's get our exact points. Can I put in negatives to a cube root? Yeah, you can put them in an odd root, just not an even root. So the cube root of 0 is 0. Cube root of 1 is 1. What's another number I could do the cube root of?
8.
8. Cube root of 8 would be 2. What about cube root of negative 1? Negative 1. Cube root of negative 8? What's the domain of the range? Is this one increasing, decreasing, constant? What's it doing? Increasing the whole time. Good. Absolute value. What's that look like? A V. Good. Absolute value of 0 is 1, 2, negative 1, negative 2. Yep. It just takes whatever you put in and makes it positive. domain of that one? What about the range? What's the first section doing? Increasing, decreasing from negative infinity to 0. What's the next section doing? Increasing after that. Good. Questions on any of those? Then let's go into a little bit different. Piecewise functions. There's not a clear-cut rule that a piecewise function always looks the same. Piecewise functions are essentially just defined differently on different parts of the domain. Okay, you have multiple pieces that you have to graph. So if I am looking at this one, we're just going to graph a few different piecewise functions to get an idea for what they look like. This one has two different pieces to it. When we did these back in Algebra 2, the rule was basically make a t-chart for each piece of the graph. So I have two different pieces, I'm going to make two different t-charts. Okay, if I look at this first one, we have to think about what x value to plug in first. So you have to look at your stipulations here. If I'm graphing that first piece, this is true when x is less than 1. Even though there's not an equal to, 1 is going to be the first thing that I plug in. Now because it doesn't have an equal to, what will I do on my graph when I graph? Open circle. Good. And then, what other kinds of x values do I pick? Right. Less than, so things smaller than 1. So maybe a 0 and a negative 1. And I'm going to plug those into this piece. So if I put in a 1, 2 times 1 is 2, plus 4 is 6. If I put in a 0, 2 times 0 is 2, plus 4, 2 times 0 is 0, plus 4 is 4. If I put in negative 1, 2 times negative 1 would be negative 2, plus 4 is 2. So I'm going to graph this at 1, 6. We have an open circle. And then we have 0, 4, negative 1, 2. When I connect these, does this line extend both ways? No. This was my starting point, my open circle. So it starts there and it's only extending this way. Okay, so the thing about those piecewise, you have to watch your starting and stopping points. You only extend it in one direction. Now let's look at the second one. What's the first x value we plug in? 1. And then what kinds of numbers? 2. Okay. Things bigger than that. When I look at this one, does it need to start with an open circle? No. Why? Greater than or equal to. So we don't need the open circles. So if I put in a 1, 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. So we've got 1, 3 is closed. 2, 2, 3, 1. So it starts and it extends this way. Any questions on that one? Is that one continuous? No. Because we have a break in our graph. It's continuous from negative infinity to 1 and from 1 to infinity, but not the entire time. What's the domain of this? This red piece stops at 1, but the blue picks up there and keeps going, so we do eventually hit everything. The range, these pieces are going down forever, so it's coming from negative infinity, and it stops at 6. So it would be negative infinity to 6. The 6 was an open circle, so it would get a parenthesis. Why don't you guys try to graph the next one? So first piece you have to start with 0 and then things smaller than that. It will be a closed circle. So 0 minus 2 is negative 2. If you put in negative 1, opposite of negative 1 would make it a 1. Minus 2 is negative 1. Put in negative 2, you get 2 minus 2, which is 0. So 0, negative 2, negative 1, negative 1, negative 2, 0. So the first section should look like this. Second section, we have to start with the 0, but what will happen there? It'll be an open. If you plug in 0, you get out negative 2. So 0, negative 2 is open. Then you need things greater than that. You can put in a 1, or if you recognize that you're going to be multiplying by a half, if you don't want fractions and decimals, just put in even numbers. You can put in whatever you want. So I may do a 2 and a 4. So if I put in a 2, 1 half times 2 is 1, minus 2 is negative 1. Put in a 4, 2 minus 2 is 0. So what happens if you have an open and a closed circle at the same spot? It's closed. We just leave it closed. So then we have 2, negative 1, 4, 0. So we're just starting here. We're going to leave it closed because it was already closed by one of them. And it looks like that. A good rule of thumb at the end, if you're not sure, do a quick check and make sure it is a function. So make sure it passes the vertical line test. If you accidentally extend a line the wrong direction, it won't be a function and you'll catch it then. So just do a quick check on your graph at the very end. Okay. You guys still with me? We want to keep going. We don't have a ton left. Maybe we just talk about just do the last couple piecewise problems today and then stop there. Then tomorrow I'll do the last little bit on greatest integer and then have work time after that. That'd be okay with everyone? So we'll do at least one of these. We don't necessarily have to do both. I put 2 on there if we needed it. So we'll do the first one. You guys can tell me what we need from there. So I gave you a piecewise function, and I'm just asking a lot of different questions here. When I say find f of 0, if you just looked at this equation, how would you get f of 0 from that equation? Plus 0 and for x. Do I do it for all 3 of these pieces? Right, just one. I'm only going to get one answer out. It's a function, so I have to look. 0. Is 0 between negative 3 and 1? Is 0 equal to 1 or is 0 greater than 1? Between negative 3 and 1. So I'm plugging it in the first piece here. So when I say f of 0, you might have to come out to the side or whatever. Then I'm plugging it into the first piece, so the opposite of 0 plus 1, which is just 1. So you have to watch. You're only going to get a single answer. Plug it into the correct piece for that. Second one, f of 1. If x equals 1, which piece am I plugging it into? Second one. And that one just says 2, so it means you're just getting out a 2. Third one, f of 2. Which piece do I plug that into? Last one. 2 is greater than 1. So we get 2 squared, which is a 4. On part B, I'm asking you for the domain. Why don't we do C first? Why don't we graph it and then we'll do domain and range from the graph? I think that might be a little easier. How many pieces will I need for this? 3. Okay, so the first piece, this is a little bit different than the others we've done because it has 2 endpoints. So when you graph this, I have to put in a negative 3. I have to put in a positive 1. Then you can do something in between the two. So maybe a negative 1. Will this extend either direction? It's only between negative 3 and 1. This one has 2 stopping points, so we won't extend it either way. Are both of those open, closed, what? Right. Okay, so if I put in negative 3, opposite of negative 3 would be 3, plus 1 is 4. If I put in negative 1, opposite of negative 1 is 1, plus 1 is 2. If I put in a 1, opposite of 1 is negative 1, plus 1 is 0. So I have a closed circle at negative 3, 4. And 1, 2, and at 1, 0, it's open. But because we had 2 endpoints, this does not extend, it just stops. Okay, second piece. What is that going to look like? 2 if x equals 1. When I make my t-chart, what can I plug in? 1. What do we get out? 2. Does it extend anywhere? No, it's just a single point. So 1, 2 is just a point on my graph. Last one. X squared if x is greater than 1. So we have to start with 1, open or closed? Open. And then things larger. So maybe a 2 and a 3. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So 1, 1 is open. 2, 4, 3, 9. So we're getting part of a parabola here. Maybe. It only extends one direction. Okay. So now I can answer those other questions. B was, what's the domain of this? So as I go from left to right, this thing started at negative 3. My red piece ended at 1, but I do have a closed circle at 1 with the blue dot. And then the green keeps going forever. So my domain would be good. Part C was the graph. D was the range. So if I'm starting at the bottom, my lowest value is 0. We don't hit it, so that's just a parenthesis. Comma. Okay, the red one hits everything until you get to here. The green one's still going up forever. Positive infinity. Okay. E. Is this entire graph continuous? No. We have a break in it. We could give sections that were continuous, but overall it's not. Okay. Questions for me? So we have another example like that. I'm stopping for today. If we need to do that one tomorrow, we will. And then the only other thing we have to talk about tomorrow is the greatest integer function. If you look, the homework is printed on that handout, I believe. So if you wanted to get a head start, you do have about 6 minutes left of class right now, so you might get a few of them done. 1 through 10, I believe, are just asking questions about some graphs. So it's like multiple choice, you know, which one is the graph of x squared, tell its domain, so it's just asking you some questions about those. So you do know how to already do the majority of this assignment. So tomorrow, it won't take me very long to finish up, and then the rest of class time will be time to work on this.
Do you know when it